So I got this file from the tutoring resources page, and here it's a combination of Natalia's file and Noah's file. So all the all the possible questions for the exam 4 that I could find. And explaining for me is the best way of memorizing it. So let's get to it. So here they're asking me for the net present value of the project. And we have these information. To find the net present value of the project, the best way that I found is to create a little chart with all of the cash outflows and all the cash inflows that we can get. So the machine cost, that's my investment. And the money is leaving my pocket now, and it's going to be, if I buy this machine, $300,000 less I'm going to have. So it's leaving my pocket. That's why it's in a negative. And I have already used this one, though. It's really great. Then the machine is going to have a useful life in years of 6 years. So I'm going to have 6 years. Okay, already used this information right there. What else do we know? The old machine salvage value is $7,000. So salvage value, it means when I sold my old machine, I got $7,000 back. And so that's an inflow, it's positive. The salvage value of the machine I'm going to buy is $12,000. So at the end of the 6-year period, I'm going to get $12,000 when I sell this current machine. Now, the cash inflow that I'm going to get here is as a savings, right? So I'm going to have reduced labor cost per year, $100,000. I'm going to save $100,000 per year by investing in this machine, and we're going to consider that an inflow. So cash flow, when they say cash flow, they are saying inflow, $100,000. This is for 6 years. Okay. Is there anything else? Oh yeah, working capital. So we know that usually they set this less. I'm not sure if it's relevant, but anyway. So working capital. We know that when we start a project, working capital is considered an outflow. So it's like money has left, so it's negative. And then here, at the end of the period, when it's released, is an inflow. So here it's positive. Then we do the totals. So this is the sum of those numbers. This is how much I'm gonna spend now if I buy this machine. Oh, wasn't it 300,000? Well, but remember that I got some back from the old machine. So right now I'm gonna have to spend 295,000. And how much I'm gonna make? This much, right? Last year I make a little bit more because my working capital is going to be released and because I can sell the machine. So if we did it in the wrong way, we could just say, oh, I'm investing this much and I'm going to get profit. It's going to be a sum of those, right? All of my cash inflows. And then we can say, not my profits. I can say my inflow is going to be this, so my profits are going to be my investment, which is negative, plus the inflows. Oh, this is going to be a very profitable project, we might think, right? $319,000. But if we do it this way, we are ignoring the fact that a dollar in my hand today is more valuable than a dollar in my hand tomorrow, inflation and all of that. So this inflow right there, like $614,000 in the future, is worth less now. So how much would that be worth today? So how do we do that? First, we have to figure out the present value of cash flow. When they say cash flow, you're saying the inflows. So we do that by using this formula. Net present value of my rate, which is 10%, plus all the totals. It's not the sum of the totals. Look, if I do net present value of this rate and the sum, it's going to give me a different number. So that's not it. It's the net present value. See, value, value, and just selecting all of them together. Rate and selecting all of the totals. It has to be done this way. It means that $614,500 that I'm going to get in the future because of this rate, it's worth only $443,000 today. So if I invest this, and that's completely a present value, it's leaving in my pocket now, right? I'm gonna get $443,000 in today's money. So how can I measure my profits or my net present value of the profit? So I would say the net present value of the project is the same as my profit in today's money, right? And I just do a sum of those two, and this is the right answer, $148,000 to 111. Now let's compare with this. If we just use like a more, I think, traditional method, or not traditional, but what anyone that is not an accountant would do, we would have a very wrong estimate. We would think, look, almost double, right? And these are profits in today's money. That's what the net present value of the project is. Okay, so for this second exercise, this one is asking us about the simple rate of return. And we know that the simple rate of return is the annual net operating income divided by our initial investment. So let's say more organized here. So annual net operating income divided by initial investment. That's the formula that I'm going to use. So do we have any of that information? That's the only thing that we were given. Well, we have the machine cost. That's my initial investment. So okay, I have that. What about my net operating income? So we don't have that information, but we can work backwards to get it. And Natalia posted this little graph that really helped me. So we know that when we have cash flow, if you do this, cash flow, depreciation, oh, that's too big, isn't it? Just make it pretty. We have cash flow, and then we have depreciation and net operating income. So look, when you want to go up, you're adding depreciation. So to convert net operating income to cash flow, you add depreciation. But when you want to convert downwards, you have your cash flow, you wanna convert it to net operating income, you go down, so you subtract depreciation. Okay, does it help? Does it help at all? Do you have any of that information? Well, we know that there is no salvage value, and the useful life of the machine is just 9 years. So that means that I'm going to use the machine for 9 years, and it's going to be worth nothing later. So I know how much of depreciation I'm going to have every year. So depreciation is going to equal this amount divided by its useful life. That's my annual depreciation. That's why it says they use a straight line depreciation. It means it's going down and just in the same rate, right? It's a straight line. Okay. We have depreciation already. Do we have cash flow? So what we do know is that this machine is going to pay itself back in 5 years. So if it pays itself back in 5 years, you know that the cash flow is this divided by the amount of years. That means I'm going to make $14,400 every year. So to go from cash flow to net operating income, I just subtract depreciation. So net operating income is going to be the money I'm making or bringing in every year minus my depreciation. So we just divide those numbers. I divide this than my annual net operating income. And my initial investment, I'm going to get this decimal number because the simple rate of return is usually expressed as a percentage. That's the answer. And this is the right answer. So look how interesting. This little thing she posted really helped me a lot. Okay, so this is the third question that we have. It's about, we are given all of this information and we are asked the payback and the simple rate of return. So this, we just have to memorize the formulas, and the payback formula, it's super big. We do initial investment, and we divide that by our, and I'm super reading it because I haven't memorized that yet, by the annual cash inflows. It's cash flow, but I always think about cash inflow. And the simple rate of return, it's equal to, take our initial investment, but in this area right there, oops. And then we actually are going to divide annual net operating income, and we divide that by the initial investment. So we have all of the information. I think we do. Let's see. The initial investment is 42,500. Annual cash flow. So we're gonna have an inflow of savings, right? When we save money, we consider that an inflow of 5,000. So our payback should be this number divided by that one. And in 8.5 years, we're gonna pay back our initial investment. Now, do we have net operating income? We don't, but we can remember that little thing that we saw in the previous question, right? So we can have, if we have cash flow, and then we have depreciation and net operating income, and if we're gonna go and convert it upwards, I add depreciation or I reduce depreciation. And I do have my cash flow, and then I would have to add depreciation. How much is depreciation? Well, I know that it costed me this, and I'm gonna, oops. I know that it costed me this, and I'm gonna get back 10,000, and I have to divide that by its useful life. So that's depreciation. So if I take my cash flow and I subtract my depreciation, I get my annual net operating income. And I do have my initial investment. So I divide this over that, get a very small number that, if expressed as a percentage, is going to give me my simple rate of return, and that is the right answer. This one is asking us for the payback period, right? And we use this method when it's not constant, when we have like different inflows every year. Because when we have the same inflow every year, we just do initial investment divided by annual cash flow. But for uneven ones, we do it here. So I like to think that about this just as our like bank statement. So I would do my balance here. So I invested this much, right? Investments could be expressed as negative numbers, then we would just have to sum it up here. But let's suppose I invested this money, but I got this back. So my balance is, I still haven't gotten back this number. So for now, it's whatever I haven't recovered plus whatever I spent minus what I got back. So my balance is this number. Let me just bring it down. I see that it's negative here, so I'm just making money back in year 5. So it took me 4 and a little bit of years to get it paid. So we know it's answer D. Like how much, 4 and how much. You can take this number, this, how much of this number is a percentage of this one? 29. So it's 4 and 29. And that's the right answer. But now let's suppose the numbers were negative. I would do it this way because it's, I think, just more intuitive, right? It's just a sum, oops, of those. It means that I spent this much and I got this much back. How much and I still in the negative. And here is this plus, oops, minus. Actually plus because that's a negative. Plus this, plus that. And it's the same thing. Just because we changed the signals here, I think it's more visual for me. And negative, 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 negative. Year 5 is the first year I'm actually making money. So I paid everything back in year 4 plus a little bit of it in year 5, 4 and a little bit. That's the right answer. Okay, so here it's about the project profitability index, and that formula here is asking about the present value of cash flows. The thing is that this formula equals the present value of cash flows divided, let's use a little symbol, divided by the investment required. Investment required. And that would be the little formula. And we do have 2 of those already, right? We have 2 of those values already. So we know that this number is the same as X divided by that number. So we could say that's the formula. In other words, we just have to multiply, right? If this is dividing, we go it's moved to the other side by multiplying. So X, or in this case, the present value, is the same as this number times this number. And this is the present value of cash flows. And that's it. That's the right answer. So this one, we just have to remember a little table, and that is when the discount, oops, just change colors. Let's use this one. When the discount rate equals, better, let me just redo it. So when we say when net present value equals 0, then therefore discount rate is equal to the internal rate of return. So if we know this, then this answer is very easy, right? Because here it says if discount rate is 10% and net present value of the project is 0, then what is the internal rate of discount? And is the same as the discount rate. The discount rate, it's the expected rate. The internal rate of return is the required rate. Now we have 2 other possible situations. If this is more than 0, so if it's a positive number and if it's a negative number. And in all of them, we can establish a relationship between the expected rate, discount rate, and the required rate. So that's it. If the discount rate, which is my expected rate, is smaller than my internal rate of return, which is my required rate, then my net present value is positive, and conversely right here. So a common size financial statement is horizontal analysis. Is this true or false? And the answer is false. Why? The answer is false. Why? We just say when it's common size, it's vertical. Why vertical? Just think about it. You're comparing everything to sales. You have like net operating income, you have cost of goods sold, and are comparing, dividing that by a number on the same vertical column. So let's say sales, so you're dividing A over B, and then C over B, you're comparing it vertically, and that is the common size one. We say the horizontal one is the one that we call trend, and it's called horizontal because we are comparing different years. So you have your income statement of year one, of year two, of year three. See, like as a horizontal line, and you're dividing this result by year one. So this is 1.5 or 150% higher than year one. So horizontal, I think this is what we have to remember, equals a trend. Oops, there's a D there, just imagine it. And when it's vertical, we are comparing all of this against one of the numbers in the statement. Okay, so this one is asking about the present value of the lease payments. So this corporation has entered into a 7-year lease for a building it will use as a warehouse. The annual payment under the lease will be $4,781. The first payment will be at the end of the current year, and all subsequent payments will be made at year ends. If the discount rate is 6%, the present value of the lease payments is closest to, okay, so we know we have 7 years, right? Set those 7 years right here. And you know that every year you're going to spend $4,781. That's how much we are spending, right? Oops. So, and we also know our rate, let's set it up anywhere here, is 6%. So then if we use the formula net present value of, so equal to net present value of this rate and these price right there, we are going to get the right answer. But what does it mean? Let's suppose you're about to rent a house, inflation is close to 6%, and you want to know how much you're actually going to pay. So let's suppose you're going to pay this every year, right? We just sum them. You could think, oh, this house in 7 months, let's say it's going to cost me $33,000. But $33,000 are worth, a dollar today is worth more than a dollar in the future. So if I take $26,000 and invest it at a rate of 6%, I'm going to be able to pay all of that during the year. This is, I think, the important part that we get from this class, because I'm not going to remember all those formulas, let's be honest. But just understanding that the present value of a dollar today it's going to be different than a dollar in the future. So paying at the end of 7 months $33,000 represent $26,000 of today. So this pharmacy has purchased, they're asking for the payback period, right? There's a lot of information, but we are solving for the payback period. And we know that there are 2 ways of solving for that. We have the initial investment divided by the annual cash flows. That's when it's a constant cash inflow every year. When they say cash flow, they're saying cash inflow. And for times when we get like different inflows every year, we do the little like bank statement thing, right? So right here, they're asking for the payback period. We know that so this pharmacy has purchased a small auto for delivering prescriptions. The auto was purchased for $29,000. So my initial investment is $29,000. You will have a 6-year useful life. I don't think I need that. Delivering prescriptions, which the pharmacy has never done before, should increase gross revenues by $32,800. So this is my gross revenue. And the cost of this prescription to the pharmacy will be, what is cost of goods sold, right? Will be $26,600. We kind of don't need that right there. So what I know is payback, initial investment annual divided by annual cash inflow. So my initial investment is this, and my cash flow or cash inflow is the same thing as whatever I'm gonna make minus my cost of goods sold. So if I take this and divide it by this number, I'm gonna get this, which is 4.7 years. I think the secret right here to this exercise is to figure out that my cash inflow is not this money. This is not what it actually is coming to the company, because it costed me 26,000 to get this money. So that is my income, right? That's my inflow, whatever is actually coming to the company, and that is the answer. Okay, so in this exercise, they are asking for the simple rate of return, and the simple rate of return is equal to my annual net operating income divided by my initial investment. That's what I have to memorize. So let's see. The management of this corporation is investigating automating a process. Old equipment with a current salvage value of $24,000, this could offset my initial investment, would be replaced by a new machine. The new machine would be purchased for $426,000 and would have a 6-year useful life and no salvage value. By automating the process, the company would save $147 per year in cash operating costs. And that's my cash inflow, right? The simple rate of return on the investment is closest to. So my initial investment is $426,000, but then I get whatever I got from selling my old machine, $24,000. So this was offset with what I got from my old one, right? So let's say my initial investment is this one. And net operating income, do we have to consider depreciation? I think so, I would say so. Do I? Check. We do have to consider depreciation because mine is that little thing again, and let's draw it again. So I have my cash flow, and then I have depreciation, net operating income. It goes up, it goes down. And the information that I have is that my cash flow, my cash inflow, right, is $147,000 per year. But then to get net operating income, I have to subtract depreciation. How much is depreciation? We know this new machine has no salvage value, so I'm not going to get anything at the end, because depreciation should be my initial investment minus salvage value, if there is any, divided by my useful life of the machine, right? So let's say the machine costed this. I have no salvage value, so just have to divide it by 6 years. This is my depreciation yearly. Now this is how much money I'm getting into the company, right? My cash flow. So my annual net operating income is equal to the money I'm getting minus depreciation. And if I divide those two, this divided by that, and I get this number that it's a decimal, so if I express it as a percentage, there we go. I have that answer, and that is the right answer. So almost done. So here we go. The following data pertain to an investment proposal, blah, blah, blah. Use Excel, of course, I'd never do it any other way. The net present value of the proposed investment is close to. So net present value, how much is my profit in today's dollars? So I would do the little tab, and what we know is that we have now, and then we have 5 years. So 1, 2, 3, 4, 5, 6, just 5. And my investment So I'm spending $40,000 now. It's a negative because it's money outflow. It's leaving my pocket. And by doing this investment, I am going to get savings. And savings, we can consider that as an inflow, right? Of $11,000 for each of the 5 years, because it's annual. And then at the end of my project, I'm gonna sell my machine and get back a salvage value of 5,000. That's also an inflow, so it's positive. My rate is 10%. So what about my totals? I just sum those numbers, and I'm gonna copy that here. So in the first year, I'm $40,000 poorer, and then this is how much I'm going to get back. I get a little bit more in the last year because I have a salvage value. Now, to figure out the present value of the inflows, of the cash flow, they always write, I have to get this first, I do net present value. It's kind of confusing because you're using net present value to solve, you're using this formula to get the present value, but that's it. This formula is going to tell me how much these inflows are worth in today's dollars. I'm going to use a 10% rate and select all of these. It's not the sum. I have to select value, 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 value. Instead of clicking in each one individually, we just drag that selection. And that's the answer that I have for the present value of the inflows. But they're not asking that. They're asking for the net present value of the proposed investment. So the net present value of the investment or the project is the difference of how much I'm spending in today's money and how much I'm getting in today's money, right? So when they're asking for this, they're actually asking the net present value of the project or of the investment. They're asking me, what is my profit in today's money? So I can compare apples with apples and bananas with bananas. I don't compare today's money with the future money. That's the right answer. And just to compare, if let's suppose we don't have an accounting mind. So we say, oh, I'm investing this money today, but I'm gonna get as a return, let's suppose we do this, all of these money. So if we don't have an accounting in mind, we could say, oh, and this is a negative number, right? Sorry, I'm investing this amount, to get this. So my profit, we could say wrongly, would be $20,000. But if we compare it to today's profit, if we compare what I'm spending today with the current value of all this income, it's much less profitable, right? So I think that is the main point. And I'm being redundant because this video is for myself actually, but this is what I have to have in mind. Always compare today's dollars with today's dollars. We are comparing apples with apples, and I cannot compare today's dollars with future dollars. Okay, so this one is just to check if we know the formula. So it says the management of this corporation is considering a project that would require an initial investment of $47,000. No other cash outflows would be required. The present value of the cash inflows would be $66,080. The profitability index of the project is closest to. So the profitability index formula, we got it around here. Present value over the initial investment. So my present value is the present value of the cash inflows would be 66,080, and my initial investment is 47. Just have to divide both, and that's it. 1.41. Okay, we have one more that we are going to use the little graph that we used in several of the other ones that I cannot remember where they are right now. Yeah? Like that one. No. Okay, so we have one more that we are gonna have to calculate the net present value. So we're gonna use something very close to what we did here in question 4. Now, Allen College has a telephone system that is in poor conditions. The system can be either or either overhauled or replaced with a new system. The following data have been gathered concerning these two alternatives, blah, blah. Okay, a rate of 12%. Allen College uses a 12% discount rate and the total cost approach to net present value analysis. Total cost approach, so they considered everything. Both alternatives are expected to have a useful life of 8 years. So it doesn't matter if I just fix my present system or if I buy a new one, it's going to have an 8-year useful life. The net present value of overhauling, so they just are interested in the first one, the system is closest to, so I'm going to have now and 8 years, right? So 1, 2, investment, and then what other information do we have there? Do I have to put my investment here if I'm analyzing this one? Actually, I don't, because this is a sunk cost. I can just ignore it. This is not relevant anymore. Accumulated depreciation doesn't go in here. It's not a cash cost, right? A cash expense. The overhaul cost needed, yeah, that's what I'm gonna need to fix. So overhaul, that is negative. I'm spending this money, $80,000. Annual cash operating costs, yeah, it's gonna cost me, it's a negative $30,000 every year to operate a system. Salvage value now, well, I'm not gonna sell my system now, but I am gonna sell it in 8 years. So I'm gonna put it back here, and that's a positive number, right? Because I am getting it back. Okay, so continuing here, if I do my totals, these right there above, and then just put it there. Okay, so right now it's gonna cost me 80,000 every year, blah, blah, blah. In the last year, it costs me a little bit less because I'm gonna get back the money from selling the machine, right? So what is the present value of all of these outflows? So the present value of outflows, oh, and the rate is 12%, so 12%. This rate, and I formula net present value for this rate, and all of these values right there, right? My cost. So it means that, because I could just sum those up and think, oh, I'm going to be spending this amount of money, but actually the present value is this one. But they're asking for the net present value of fixing the system. Net present value is like the profit in today's dollars. So you have to sum both of those. And that is the right answer. This is telling me that fixing the system in today's dollars is worth $228,221. That's my actual cost in today's value, right? If we were thinking about, oh, just adding all of that together and if we don't consider the present value, it's going to be a much larger number.